Hey, it's John here, and we are looking at 4Clojure number 76, Intro to Trampoline. And this was a little bit new for me. I haven't dealt with mutual recursion before, but Trampoline allows you to run mutual recursion without blowing up your stack. Okay, so I looked up on Wikipedia some example for mutual recursion, and they give you the trivial example of defining is odd and is even in terms of each other. And here's what it is. Basically, if you say for the is odd function, here, let's make question marks. Is odd, you basically look to see if the input is 0, and if it's 0, then it's not odd. Otherwise, you call is even on one less than what was given to you. And then when you go to the is even function, it does the same thing. If n is 0, then it's true. Otherwise, call is odd with a decremented argument. Alright, so pretty silly example. Obviously not efficient, but it gives you an idea of how you could use mutual recursion. And so first thing is, if I define is odd and it's defined in terms of is even, then I have this sort of ordering problem where one of these has to be first, and then it's defined in terms of the other one, which comes later, which is a problem. And there is this declare macro, which will just create the var but not bind anything to it. So we at least have that var that we can reference, and then later on we actually define it for real so that it can be used at runtime. So we can do declare is even, define is odd, define is even. Okay, so now whenever we call is even on, say, 50, then we'll get true 500, 5,000, 50,000. Okay, Stack Overflow at 50,000. Fair enough. So for regular recursive function, you say, oh, I just need loop recur. But that doesn't work here because you're not recurring on the same function, you're recurring on something else. So this is where Trampoline comes in. And so if we Trampoline on is even the function, and our value is 50,000, well, that doesn't work. But if we change the return values here from function if we change the return values from being just numbers to function calls, then Trampoline has the ability to do the tail recursion, basically. Some optimization on the stack. Alright, so let's try that. We'll redefine those. And we see, now we can run is even with 50,000 or 500,000 or really big numbers. Takes a little longer, but it eventually gets there without blowing up. So that is how Trampoline works. So now we can look at our function here. And let's see, now there's this let function probably a macro, and basically it is going to let us do mutual recursion. If we just did let, then we'd probably have the problem that things are defined in terms of each other and won't work. So we look at, okay, our function foo says evaluate bar with conjing x and y, and foo is, that was foo, and bar is if the last one isn't bigger than 10, then return x, otherwise call foo with x and 2 plus y. Okay, so we call, our initial thing is to call foo with an empty array and 1. So foo comes in, empty array and 1, we're going to conj 1 and the array. So we have an array of 1, then we're going to call bar with the array and 1, and bar doesn't meet this condition, last is 1, so we come in here and we have x is our array, and then y becomes 1 plus 2, which is 3, which will come back here, and 3 will get conged, and then it'll be passed back with 3, and it'll keep going. So it looks like it's just going through everything, adding, it's just adding 2 to some accumulator and then conjing that into a list. So our list is sort of this accumulator, and then our current value is 1, 3, 5, 7, 9. So we're going to get all that until the last one is greater than 10. So it'll be 1, 3, 5, 7, 9, 11, 13, and then 13 would come back, or sorry, 11 would come back and be higher and get returned. So let's just evaluate it. I think we sort of see what's going on. Let's just evaluate it and see what we get. Okay, 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. All right, great. Thank you for watching.